Let's look at distinguishing age, height, race, and gender using bones. To start with, we'll look at gender. So we can look at the skull, and from different characteristics of just the skull, we can tell male or female. So this skull, these skulls down here represent male. These skulls over here represent female. So we know that the male skull is actually a lot more massive, and it appears bumpier than the female. And the frontal bone, which is the bone here, like in your forehead, is low and sloping in male, where it's actually going to be a little higher and rounded in the front for female, like this. The female also has a lower jaw that's going to be sloped, and her chin is going to be a little bit more V-shaped, where the male chin is going to be a little bit more square. Then we can look at the eye orbits, and the male eye orbits are more square. They're not going to be perfect squares, but you can see that they're a little bit more square than the female eye orbits, which are going to tend to be more rounded. Then we can use the pelvis, and this is one of the best bones in order to, and it's multiple bones put together, but the best to figure out gender, because the male has a distinguished heart-shaped cavity, if you look down here in this middle picture, and it's narrower than the female. So the female is going to have this oval type shape in the cavity of her pelvis, and it's much larger because remember, females are going to be able to give birth, and the baby has to be able to fit through. So that's a significant difference. And also on the topic of birth, if a woman has given birth, you'll also see parturition scars uh, from when the baby was in the womb, the tendons attaching everything to the bones. You'll see some scars along the sides of the pelvis. Then we can also look at the pubic bone, which is in the front here. And the females is going to tend to be rectangular shaped, and the males is going to be a triangle. And the subpubic angle in a female is going to be greater than 90 degrees. You see it's a little bit more open here than a male is going to have a narrower opening, and that's going to be lower than 90 degrees. And we can also look at the angle that the femur meets the pelvis. So the femur would go into the side here. And there's going to be a lower angle for the male, and you can see it's wider, so the femur would come in a little straighter. And there's going to be a greater angle for the female. We can also use bones to distinguish height, and typically the humerus or the femur are used because those are long bones. They can use other bones, and there's been databases that are established that use mathematical relationships to estimate height, and it's really just an estimate. And they use different tables for males, females, and different races. So there will be certain calculations they use if you're Caucasoid or Mongoloid or Negroid, and if you're male or female. So they have all those calculations done, and they'll plug it into the formulas and get an estimate for height. And then we can also use bones to distinguish race. So looking at this chart, you can see we divide the races into, Caucasoid, Negroid, or Mongoloid. And it's getting a little bit more difficult in order to do this because a lot of the races have become blended in a sense. So there's not going to be really distinct, um, significant differences where, at one point when they first started doing this, they saw that. So you're going to get combinations now. So it's a little bit harder to do this, but you'll still see some prominent features over others. So the first thing is the shape of the eye orbits, and they're going to be rounded and somewhat square if you're Caucasoid, where they'll be rectangular if you're Negroid, and rounded and somewhat circular if you're Mongoloid. The nasal spine is actually a little bone in the nose we'll look at in a minute. You can look at that, and it's going to be somewhat prominent in Mongoloid, where it's going to be very prominent in Caucasoid and very small in the Negroid. The nasal index you'll look at when you do your lab, and prognathism we'll look at in a minute, and the femur. Now you can actually lie the femur down, you'll look at this in the lab also, and if you can slide your fingers underneath the curve of the femur bone, it can either be Caucasoid or Mongoloid, and if it doesn't fit under the curve, then you're looking probably at somebody that has some Negroid descent. So if we look at the chart of the different races, just looking at the skull, a prognathism is actually sort of the angle of the jaw. So if you look at it, if you actually hold a pencil up to your mouth, you can figure out what yours is like as well. So someone that's Caucasoid is really not going to have a prognathism. It's straight. And then Mongoloid, it's going to be variable, so going to have somewhat of an angle here, and in someone that's negroid, you're going to see much bigger prognathicism. So this jaw line is actually going to have an angle to it. Now, we mentioned the nasal spine before, and it's actually going to be this little bone down here that sticks out. So it's going to be very prominent in the caucasoid, and you can see that right at the top of this red line here. That would be the nasal spine. And then we can distinguish age from long bones as well. So when the head of a long bone has completely fused to its shaft, will give us different timelines. So they figured out when each one will fuse. So you can see the lines here representing there's no union here, and then here you have this other bone that's, there but unfused, and then when it's completely fused and then obliterated and broken off. And we can also use cartilaginous lines. So an epiphysis is a line that's visible as the cartilage is being replaced or ossifications occurring, and those osteoblasts are filling in those spaces. And when that process is complete, then the line is no longer visible, and that will give us another indication of age. And the skull is also used for distinguishing age. We talked about the soft spot in the last lecture, and this is why. The bones are still not completely ossified, they're growing, but you also have all of these sutures. And you can see each one has a name: coronal, sagittal, we have the lumboidal. And this is an actual picture of what these suture marks look like. It kind of looks like the bone is stitched together. And we know that the different suture marks will fuse at different ages. So the coronal suture is actually closed only about the age of 50. So that takes some time. And then the lumboidal suture begins closing, okay, this one in the back here begins closing at age 21, closes a little faster around 26, and is closed completely at the age of 30. So even though you're a little older, you still have bones that are fusing together.